section 4.3.2. Y equals minus 2x plus 3. And the way we're going to do this is we're to find the ordered pairs to graph this. We're going to go x and y. And I'll pick arbitrary values for x and plug into that equation and then find the corresponding y value. So you can pick, usually a negative number, 0, and a positive number are good for these problems. And I'm going to pick a -1. Don't pick too large absolute value numbers. And then what we're going to do is we're going to put -1 in for x. So I'm going to put -1 in there for the x. So -2 times a -1 is a +2. +3 is 5. So 5 would be the y value associated with -1. Now I get -2. And I'm going to put 0 in place of the x. -2 times 0 is 0. Plus 5 is a +5. +3. I don't know how I got plus. Somehow I changed this. I don't know why I put +5 and +3. But that will change this. And that'll make this a +3. Everyone with me on my incorrect math there? Then it's a -2. I replace the x with 1. So I got -2 times 1, -2 plus 3 is a 1. So now I have these ordered pairs that I'm going to plot. And so I'm going to go now I put -5, -1 plus 5. So I come back 1, and I go up to the top of here. This particular point right up here is a -1, 5. Then I'm going to go 0 plus 3. So that would be this point. And then 1 and 1. So I go out 1, up 1. And then I'll join the points. And notice that that's a straight line. Now, it's always going to be a straight line as long as this equation right here, the exponents here are y to the first and x to the first power. Whenever it's not there, it's understood that it's first power. That makes a linear equation, and it graphs to a straight line. Why do you do 3 points? 3 points because, you know, in a straight line, any 2 points, you join them as a straight line. You do 3 points just to verify that you have done the plot. Then if it goes through all 3 points, you know, you've done it correctly. Now the next one, 6. It's y equals 3 fourths x plus 2. Now, when you do this little t, you could choose minus 1, 0, and 1, but a little bit of judicious choice could help you, because if you choose minus 1, you notice the first term is going to be a minus 3/4, and you'll have to subtract that from 2, and then you're going to get 1 1/4, which is 5/4. So you're graphing fractions. How can you avoid having fractions? Well, the way to do it is choose an x that will not give you a fraction. One value of x would be minus 4. When you put that in for x, and you go 3/4 of a minus 4, you'll get a minus 3. Right? So now you don't have to deal with fractions. Not to say having fractions is incorrect. When you plot it correctly, that it will give it the right values. But this just makes it easier. Then go 0, because 0 is just going to wipe out that 3/4, right? 0 times 3/4 is just going to be 0, and you're going to have 2. Then on the positive side, go to 4. Now with judicious choice of x, you made your problem simpler to solve. Not to say any other choice is wrong, it's just you just be wise in order to make your problem as simple as possible. So once again, I'm going to put minus 4 in for the x. Now then, when I go 3/4, notice this 4 and that minus 4 in the numerator make a minus 1, right? This becomes a minus 1. So then 3 times a minus 1 is a minus 3, plus 2 is a minus 1. Then I'll go 3/4 of 0 plus 2. Now 3/4 of 0, this value becomes 0, because 0 times any number is 0. So then I have plus 2. Then if I go 3/4 and put my 4 in, the 4 and the 4 make 1, right? And then 1 times 3 is 3, plus 2 makes this 5. Now I have these ordered pairs that I'm going to plot. So the first ordered pair is a minus 4, minus 1. So I'm going to go 1, 2, 3, 4. Kind of got a little bit of a mess, but this right down here is my first minus 4, minus 1. Then I got 0 and 2. This is going to be 0 and 2. The next one is 4 and 5. And it looks like I've done it right because that line is going through all 3 points. So that would be the graph of that line that would satisfy that equation. So number 8 says a y equals a minus 1/3 x, y equals minus 1/3 x plus 1. So, given what we did before, what negative number would you like choose? -3, right? Because you have 1/3. Then goes 0, and then go 3. So, when you do -1/3 plus 1, and you put a -3 in here, notice a -1/3 of a -3 is what? +2, +1. And you add it together and you get +2. Now you go -1/3. Then, when you put 0 in there, -1/3 of 0, 0, plus 1, it's going to be a +1. And it's -1/3 plus 1, and we put 3 in there. Now that's going to be a -1, right? And then we have -1 plus 1 is 0. So now we'll plot these ordered pairs. So it's a -3 plus 2. So you right up there. Zero and plus 1. Right there. And then 3 and 0. Now we'll check, make sure that we've done it right. Looks correct. Looks like we got it right because we're plotting those 3 points and they're all going to be the same value. All right. Any questions? Should be able to click through that. Notice it goes through 18, those same kinds of problems. Everyone think they got that under control. Okay, the next objective B, notice it says x-intercepts and y-intercept. So what we want to do is define x-intercept and y-intercept. So the x-intercept is the ordered pair xy such that y equals 0. That's the x-intercept. So what that's saying is that you'll have an x, or let's better say this, let's say that you will have an a, some value a in the x position, and in the y position you'll always have a 0. Now on the other hand, a y-intercept is the ordered pair XY such that, and what does intuition say that you would say? If x-intercept is the ordered pair such that y is 0, the y-intercept is the ordered pair such that x equals 0. So, in this particular case, what you'd have is 0 would always be x, and y could be any value b. That makes sense? Now, let's just look at this. You see the x-intercept where y is 0. Let's look at just hypothetical values of x, y. That particular point, if each red is a 1, would be 1, 2, 3, 4. This would be x is negative 5, y is what? 0, right? This point right here would be x is negative 3, y is 0. This is 0, 0. This particular point right out here is 4 is 0. Any point on the x-axis always has as a second element what? Y is 0. You're going to be on the x-axis. So you'll be, if that point where a graph crosses the x-axis will always be y is 0. Correspondingly, if you look at points on the y-axis, look at this point right up here. Well, there's 1, 2, 3, 4. That particular point right there is what? X is 0, y is 4. This point right here, which lays on the y-axis, is x is 0, y is 1. This point right down here, laying on the y-axis, is x is 0, y is negative 2. And down here, x is 0, y is negative 5. Anytime the first of the ordered pair is 0, you're always going to be on the y-axis. Anytime your second of the ordered pair is 0, you're always going to be on the x-axis. That's why they're called x and y intercepts. Because of those, when you cross it, the x-axis, your y value will be 0. When you cross the x-axis, your x value will be 0. And therefore, they're called x and y intercepts. So, if we are going to find, as they are specified there, in 20, given 3x plus 4y equals 12, if they're specifying x-intercept, then y has to equal what? 0. So you simply take your equation and in place of y, what are you going to put? 0. And then evaluate that. So it's going to be 3x plus 0. 4 times 0 is 0 equals 12. So it's 3x equals 12. X has to equal 1/3 of both sides, right? 4. You either take 1/3. The most appropriate thing is to take 1/3 of both sides, mathematically speaking. Factor the 12 into 4 times 3. It's not prime factored, but then this 3 and this 3 go together and become 1. So you have 4. So now what's the ordered pair? 4, 0. The y-intercept. Is going to be an ordered pair what? 0, B. So you take your equation and in place of x, you're going to put what? 0. 3 times 0 is 0. It leaves you with 4y equals 12. And y is going to equal 3. So my ordered pair here is 0, 3. So here's my y-intercept, here's my x-intercept. If I were to graph them, I would graph 4, 0, right here. 4, 0. If I were to graph my y-intercept, that would be 0, right there. And now 2 points determine a straight line. I don't have a third point to verify it, but I could draw what? My straight line. Just by using my x-intercept and my y-intercept. You think you can do x-intercepts, y-intercepts? All right. 26. Says 2x plus y equals 4. Now it's saying graph. Now, we have 2 ways to graph that equation. One is using our T method, arbitrarily picking 3 points, graphing, plotting those values. Or what's the other thing we can do? X-intercept, y-intercept. Depends upon, there's going to be other ways, but now, so far in this section, we have those 2 methods. So if we did the T method for this, and we go X and Y. But in order to do that, we would have to isolate that Y. Now in order to isolate that Y, what I'm going to do, give myself a little room here. I need to get rid of this 2x on this side. And what I'm going to do is I'm going to add a minus 2x to both sides. Why I'm going to add minus 2x? Because it's the additive inverse of 2x. The additive inverse, when you add a number and its additive inverse together, what do you always get? 0. That's the definition in mathematics. Additive inverse is something when you add them together, you get 0. Well, 2x and a minus 2x are additive inverses. So these two go together to give me 0. And then I have a plus y equals. Now I can drop the brackets on the right-hand side and get 4 minus 2x. Now I'm ready to do my t, right? Over here. What values would you plug in for x to get points? from what we just did previously. Go with minus 1, 0, and 1, right? They're going to be the easiest. Minus 1, 0, and 1. Now we put them over here on this side for x. So we're going to have 4 minus 2 times a minus 1. Well, this minus 2 and this minus 1 make a plus 2, right? 4 plus 2 is 6. Then we go 4 minus 2 times 0. 2 times 0 is 0, and 4 minus 0 is 4. Then we put 1 in place of the x. 4 minus 2 times 1. 2 times 1 is a minus 2. 4 minus 2, 2. So now we have 3 sets of ordered pairs, and we can graph that just as we did previously. So I'm going to do a minus 2 and 6. Well, that's a little bit off my minus 1 and 6. A little bit off my board, but it's up here, so I want to minus 1 and 6. Then it's 0 and 4. It's right here. And what do we call that? X-intercept y. Y. It's going across the y-axis, right? And what is true? X is 0, right? Then 1 and 2. So it's going to be 1 and 2. No. This is going to be a little bit tricky. That would be my anytime, once again, just to review about linear equations. This thing is 2x plus y equals 4. Notice that what's understood is this x has a first degree power, right? It's first degree right here. Y to the first. When there's nothing there, you understand that it's first degree. Therefore, it's called a linear equation. And linear equations always graph to straight lines. What would you estimate the x-intercept to be? The x-intercept is where the graph crosses the what axis? We said 0, 4 was what? X-intercept or y-intercept? This point right here. And we say that's x or y-intercept. Y, because it's where it crosses the y-axis. So the x-intercept is where it crosses the x-axis. Give me an estimate. What? Okay. It's right down here. Is that right? And an estimate, a good estimate would be, as she said, 2, 0. Right? Notice every straight line has an x-intercept and a y-intercept, except a horizontal line and a vertical line. You see, if I draw horizontal lines, I don't have x-intercept. except the line that goes through the right straight along the x-axis, and then every value is an x-intercept, isn't it? Horizontal lines, right? All of those horizontal lines. No x-intercepts except when you're on the x-axis, and then you got every point as an x-intercept. How about a vertical line? Does it have x-intercepts? Now think about it. A vertical line has an x-intercept. Does every vertical line have a y-intercept? Just look at all of them lines that are going straight up and down. Only one, and that's the one that's on the y-axis, right? Then every point on that line is a y-intercept. Makes sense? So horizontal and vertical lines are the ones that don't meet the criteria. As long as you aren't vertical or horizontal lines, then every line has a x-intercept and has a y-intercept, okay? Now I said there is another way to do this same problem. So 26 we have 2x plus y equals 4. What would be the second way? Okay, well, let's see, we did it this way, where we subtracted the 2x and we got x, y, and plotted 3 points. Now, what's the other way that we could do this? Find the x-intercept and find the y-intercept, right? And then we'd only have 2 points. It'd be a little bit more risky in saying that we got the right line, but we could do it that way. So let's just do it. The x-intercept, and I'm just going to abbreviate it that way, is where what? Okay, where y equals 0. Now what I can do is I can simply take my equation and for y substitute what? Y is 0. So I substitute y, 2x, and then 2 times 0 is 0. So this is plus 0, so this is just going to be 4. And then I take 1/2 of both sides, or divide both sides by 2. X equals 2. And I found my x-intercept. What is my x-intercept? Ordered pair? 2, 0. A little bit easier, right? A little bit easier, has a risk to it, because we're only going to plot 2 points rather than 3. Now we go y-intercept, where x is what? 0. See, x-intercept, y0, y-intercept, x0, right? Then we just take our equation, 2, but now for the x, we're going to put 0, right? 2 times 0 is 0, and we got y equals 4. So what's my ordered pair? 0, 4. So I'm at 2, 0. X is 2. Y is 0. X-intercept, right? And then 4, 0, or 0, 4. 0. And I plot the 2 lines. And there's my line. If you use x-intercept, y-intercept, and you want to plot a third point, just pick out anything. And notice that what you could do with this one is you could, once you got it graphed, you could say, well, I'm going to see when x is 1, just arbitrary choice, but it's between x is 1 is between this value of x and this value of x out here, right? And then see whether it lines up with y, just to make sure you did it right. So then you'd have 2 times x is 1 plus y equals 4. So that'd be 2 plus y equals 4. And then you subtract the 2 from both sides and you'd have 2. So you'd say I have an ordered pair 1, 2. And when I go out here 1 and I go up here 2, now how sure am I that that's the right line? Pretty sure. It's a way to kind of get, do x-intercept, y-intercept, and make sure that you did it right. I'll do another one doing just x-intercept, y-intercept, because I think what you'll find is that many times if you're graphing the equation, you will try x-intercept, y-intercept. It does have an advantage in that if the line is fairly steep, or maybe it has an x-intercept that is very large number, you kind of know that the line is way over someplace, or if y is very large number. So here's x minus 3y equals 6. So x-intercept. How am I going to do it? Am I going to put 0 in place of x or y? In place of the y, right? So 3 times 0 is 0, x equals 6. So my ordered pair is 6, 0, right? Y-intercept. Now I'm going to do what? What's 0? X is 0. Y-intercept, x is 0. 0 minus 3, y equals 6. So I'm going to put, now, what am I going to do? I'm going to take both sides times a minus 1/3, or else I'm going to divide by minus 3. And what am I going to get? Y is -2. Now my ordered pair is what? 0 minus 2. That's 0. If I've done this right, I should have x is 6, 3, right up here. X is 6, y is 0, and x is 0, y is minus 2. That should be my line. Okay. The next one you have to do is 36. Y equals minus 4. Now notice that this is saying no matter what x is, if x is minus 1, what's y going to be? Minus 4. If x is 0, what's y going to be? Minus 4. If x is 1, what's y? Minus 4. So what this thing graphs out to be, y is a minus 4. So if x is minus 1, y is minus 4. If x is 0, y is a minus 4. If x is 1, it's a minus 4. So what does it look like? No matter what we have a horizontal line, right? What would happen if we had x equals minus 4? Then no matter what y is, x is minus 4, right? So we would be back here. We'd be back here at minus 4, and we just draw a vertical line, and that would be x's. And this one is y equals minus 4. Horizontal and vertical lines. If you look at 40, it says a Rattler roller coaster in Fiesta in San Antonio, Texas, has a maximum speed of approximately 110 feet per second. The equation that describes the total number of feet traveled by the roller coaster in t seconds is d equals 110 t. And then they have 0 is less than t, which is less than 10 seconds. So it's graphing it. So if you were to graph this thing, what you would do, you would never go negative seconds. You'd always go positive. And what you would do is horizontally you do 1, 2, 3, 4, 5, 6, 8, 9, 10. You put 10 there, and then here vertically in 10 seconds you'd go 10 times 110. So the maximum you go on this graph is 1,100, right? So if you have 1, 2, you'd have 1,100. And this thing, in 0 seconds, you go here. And that would be the graph. You have a straight line. And the slope of this line right here would be what? 1 over how much you go up? 110. That slope is 110. For every 1 you go up, you're going up 110, right? So if you're at 5, what do you have? 5 seconds. Halfway out here, what do you have? 5 times 110, 550 feet, right? Okay. That's 4-3. So the test is, the quiz is going to be 4-1, 4-2, 4-3. There'll be 4 questions off of those 3. And then you have to hand in 4-1, 4-2, 4-3. Wednesday, beginning of class. End of class will be the quiz.